All right. Okay, so today we're doing trig ratios. This is just a review of what you guys did last year in Math 2, but we have the SBAC coming up pretty soon, so I want to make sure that we're ready for it. So if you guys remember, there are 6 trig ratios. Trig ratios, a ratio. So a ratio is just a fraction, reduced fraction. That's all it is. So when I say ratio, I just mean a reduced fraction. Okay, it only works for right triangles. So you guys remember SOHCAHTOA. Some of you might remember SOHCAHTOA. SOHCAHTOA is sine equals opposite over adjacent, over hypotenuse. Cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Okay, so those are the ratios. That's how we're going to find out each of these. And then you may or may not have done this last year, but the other 3, there's cosecant, secant, and cotangent. Okay? So cosecant is just the reciprocal of sine. Secant is just the reciprocal of cosine, and cotangent is just the reciprocal of tangent. All right? Okay, so for example 1, we're just going to figure these out. So first of all, you start with the angle. So this one is angle A. So we go to angle A. Angle A is this guy right here. Remember, the angle is the opening. So that is the angle right there. Okay? And we're figuring out the ratio for sine. Well, sine is opposite side over hypotenuse. Okay? The opposite from the pink, the opposite side, so we got 3 sides, right? We got 3 sides on a triangle. So if I'm up here, the opposite side is going to be y. So y goes on top. Hypotenuse is always across from 90 degrees. So because these are right angles, right triangles, opposite is always, the hypotenuse is always going to be the one opposite. We call these 2 legs. These 2 guys are legs because they make up the 90 degrees, and the other side is what we call the hypotenuse. So that's z. So the ratio is y divided by z. Now we're going to stay with A. We're going to do all the a's first. So A. So the next one is cosine of A. Cosine is a little different. Cosine is adjacent over hypotenuse. So I'm still at A up there, top left. Adjacent means next to. Okay? So we know this guy is the opposite, right? We know this guy is the hypotenuse. Adjacent means next to. So the side that's next to A, that's not the hypotenuse, is going to be x. And then hypotenuse is still the same, z. Okay? So now let's go down to tangent of A. Tangent, okay, so tangent is opposite over adjacent. Doesn't have a hypotenuse in it. Okay, so we're still at A. So the opposite is y. The adjacent is x. Cosecant of A. Cosecant of A. Okay, so cosecant is the reciprocal of sine. So it's hypotenuse over opposite. Okay, so the hypotenuse is z still. And opposite of A, we said, was y. Secant of A. Okay, so secant is the reciprocal of cosine. So we have hypotenuse over adjacent. So the hypotenuse is z. The adjacent, we said, was x from there. Okay, those are all the angle A's. Now we're going to move to angle B. Okay, so we're going to move to angle B now. So now this guy is not the angle. This guy is. Remember, the angle is the opening. Okay? So we're going to do tangent of B. So from B, tangent is still opposite over adjacent. So now we got to figure out what the opposite side is for tangent. Well, opposite, we're going to take a walk across. The opposite for B is side x. Adjacent next to, remember, we're not going to use this. This is hypotenuse. So the side next to it, the leg next to it, I should say, is y. So x divided by y. Sine of B. Sine is opposite over hypotenuse. So opposite is x, hypotenuse is z. Cosine. Cosine is adjacent. So again, adjacent to B is y over hypotenuse. And the last one's cotangent. Cotangent. Cotangent is adjacent over opposite. Adjacent over opposite. So we're still at B. So adjacent is going to be y. Opposite is going to be x. So y over x. And you can see some of these share answers. It's important because they're going to ask you that. They're going to ask you which two have the same exact answer. And you can see these guys, cosine of A and sine of B have the exact same answer. Sine of A, cosine of B have the exact same answer. I believe that is, nope, tangent of A and cotangent of B have the exact same answer. Yeah. So a lot of them have same answers for different angles. Okay. Okay. So the next thing. So remember, we have four parts of a graph. So we have 4 parts. So anything in this quadrant, so positive x, positive y, is going to be quadrant 1, quadrant 2, quadrant 3, and quadrant 4, because they're going to ask us questions about that next. So example number 2. Given, so they already told you what tangent is. They say tangent is 5 over 6. So there's a triangle that's in quadrant 1. So quadrant 1 means it's in this guy right here. So any triangle in quadrant 1 is always going to look like this. Okay? And this is the right triangle there. All right. Okay, so we're going to build that triangle over here. Okay, so we build that triangle here. Okay. And the angle is always going to be here. So this is angle A. So the angle will always be there for quadrant 1. Okay. So we know it's 5 over 6. Okay, well again, we know that tangent is opposite over adjacent, right? It's opposite over adjacent. So that means to have 5 over 6, the opposite, it's got to be 5, and the adjacent has to be 6. Okay. Given that, so that's what we know, we want the exact value of cosine of A. All right. Cosine of angle A. Well, cosine is adjacent over hypotenuse. Okay. So adjacent to A, remember adjacent is next to. This is the hypotenuse. We don't want that side. This is the opposite. We don't want that side. We want the adjacent, so that's 6. So 6, and then here's the problem. We don't know what the hypotenuse is. We don't know what it is. So we have to put a letter. We have to solve for it. So this is going to be our finished answer. But we need to figure out what h is. Okay, so in order to do that, we need to use something you guys have used many, many times before. It's called the Pythagorean theorem. Pythagorean theorem, a squared plus b squared equals c squared, okay, is used when we don't know one of the sides of a right triangle. Okay, we don't know the hypotenuse. So the Pythagorean theorem says a squared plus b squared equals c squared. That's the Pythagorean theorem. That's what it says. Okay? A and b are always legs. C is always the hypotenuse. Okay? So I know two legs. So 6 and 5 are going to be my a and b. So we have 6 squared plus 5 squared equals h squared or c squared. You can use either one because we called it h before, so we'll call it h again because it's for hypotenuse. Okay, we got to solve for h. Okay, so we got a 6 times 6 is 36. 5 times 5 is 25, h squared. I add these two guys up, I get 51. I don't want h squared, I want h, so I got to take the square root. The square root of 51 is, we want the exact value. Remember, we want the exact value, right? So we're not going to go to our calculator and put in the square root of 51 because the square root of 51 is 7 point something, something, something. We don't want that. We don't want to round. So what we're going to do is we're going to look on our list and see if there's any number. We're going to try to figure out if there's any perfect square that goes into 51. So the numbers on our list, 1, 4, 9, 16, and none of those go into 51 evenly. That means that's reduced as far as it can go. So this is going to be the square root of 51. Okay? So that means that goes here. That goes here. But the problem is it's not rationalized. We can't finish with the square root on the bottom. So what are we going to do? So we're going to do something called rationalize the denominator. We're going to multiply both sides by what's causing the issue. What's causing the issue is the square root on the bottom. So we're going to multiply both sides by the square root on the bottom. Okay? So 6 times the square root of 51, I can't multiply those because one has a square root, one doesn't. So I just have 6 and the square root of 51. Square root of 51 times the square root of 51 is just 51. Okay? You try to reduce as much as you can. I don't think anything goes into, let's see. Let's see. Let's see, 6 divided by 51. Oh, it can be reduced. 2/17. 2 over 17. Okay. So what I'm going to do here is I'm going to reduce. Divide this by 3, makes a 2. Divide this by 3, you get 17. So it's going to be 2 root 51 over 17. That's my final answer. That's cosine reduced. Okay? So it's the same thing with a little bit of a twist, right? Okay, so let's try the next one. So again, we still have a triangle in quadrant 1. Right? Okay, so A is here. Okay. So now we know that cosecant is square root of 57 over 7. Cosecant. Cosecant is hypotenuse divided by opposite. So hypotenuse. So that means the hypotenuse is on top. That's the square root of 57. Opposite is on the bottom. Opposite of A is going to be this side over here at 7. So that means we don't know this guy. Call this A, lowercase a. We don't know what that is. Okay, so using that, we got to figure out what tangent of A is. So tangent is opposite over adjacent. Opposite of A is 7. Lowercase a is on the bottom. We got to figure out what lowercase a is. So to do that, we're going to use the Pythagorean theorem again. Okay, so Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. Okay, so leg, A is a leg, 7 is a leg. Square root of 57 is not a leg. Square root of 57 is a hypotenuse squared. Okay. A squared plus 49 square. If you square a square root, it's just going to be the number on the inside. Just the opposite. It's like adding 2 and subtracting 2. You just get to where you begin. Okay, so now we got to solve for A. So I'm going to subtract both sides by 49. I don't want A, I want the square root of A. So I get A equals 8. Square root of 8, sorry. And the square root of 8 is actually not on my list, but I can divide it by 4. So the square root of 8 is actually 4 times 2. Square root of 4 times 2, right? And we know that the square root of 4 is 2. So really I can write this as 2 and then root 2. Okay. So now I'm going to move this guy in. So instead of A, it's 2 times the square root of 2. But again, I have a square root on the bottom. Can't have a square root on the bottom. So I'm going to multiply by what's causing the issue. The only reason there's an issue is because of that square root. So I'm going to multiply by the square root. So I have 7 times the square root of 2 because I can't multiply them because one's a root and one's not. 2 on the outside. And then I have the square root of 2 times the square root of 2, which is just regular, which is the square root of 4, right? Which is the square root of, which is just 2. So in other words, I have 7 square root 2 over 2 times 2. So 7 root 2 over 4. And 7 over 4 I can't reduce. Done. So sine of A is that. Okay. Okay, so next one. Solve for x. So x is the hypotenuse. So I have to solve for the hypotenuse, right? We can look at the picture and see that this guy is the hypotenuse. Okay? So we got to solve for it. Okay, so they give us a couple things. They say that T is the right angle. They say that angle U is 68. Well, there's only 180 degrees in total. There's only 180 degrees. So if I have one angle, that's 90. One angle, that's 68. That means I only have 180 total, right? That means I only have 22 left. So that means that last angle is 22. 22 degrees. Okay. And I know one of the legs is 96. I don't know what the other leg is. and I don't know what the hypotenuse is. Okay, so I have, what I'm going to use is the trig ratios. The trig ratios are sine, cosine, tangent, cosecant, secant, cotangent. I'm going to use one of those. Doesn't matter which one to find out what the missing side is. The missing side is this guy here, hypotenuse. So I'm going to go up here and figure out one that has a hypotenuse. So let's see what I have. So if I use this as my angle, I have the opposite, and I'm trying to find the hypotenuse, right? If I use this as my angle, I don't have the opposite anymore. I have the adjacent, and I'm trying to look at the hypotenuse. Okay? So it doesn't matter what you use, whatever angle you pick is going to determine what ratio you're going to use. So if I use S, let's say I stick with S, I'm going to use S. Well, from S, I don't know what this side is. I don't know the opposite. So I don't know opposite. I don't know opposite. I don't know hypotenuse, but I do know adjacent. And I need to find hypotenuse. So which one of the cosine is the guy that we're going to use? Because, so cosine of S, right? Because that one has adjacent. Adjacent is 96, and X is hypotenuse. And I actually know what angle S is. I know that angle S is 22 degrees. Okay? So what I'm going to do is I'm going to solve. Now you're solving for X. So we're going to make this guy into a fraction. And I'm going to do something we've done before, cross multiply. So we're going to cross multiply. So I have X times cosine of 22 degrees equals 1 times 96. Solve for X. Well, I don't want cosine of 22 degrees, and I'm multiplying by it. So I'm going to divide both sides by cosine. That becomes a 1. So now I have X times 1, which is just X. So now what I'm going to do is I'm going to put this in my calculator, just like that. I'm going to put that in my calculator, just like that. And you have 96 divided by cosine of 22. So make sure your calculator's in degrees. Make sure it says DEG instead of RAD. So we have 96 divided by cosine of 22. And you get this guy here. We're going to round that to the nearest tenth. So the tenth is the guy to the right of the decimal, so 5. So 103.5. That means 103.5. Okay. All right, so next one is exactly the same type of problem. So again, this is a right triangle. So I know that this is 23, this angle here is 23. This is a right angle, so it's 90. I can figure out what that guy is going to be. So that's the first thing I'm going to do. So 23, let's see, 23 plus 90. So far I have 113 accounted for. So total there's 180. 67. So that means this guy right here is 67 degrees. Okay, and I need to find one of the legs. Leg leg, right? Because they make up the 90 degrees. So if I need to figure out one of the legs, I'm not going to use one of the guys that says hypotenuse. So I'm not going to use sine, I'm not going to use cosine, I'm not going to use this guy, I'm not going to use this guy, and I'm not going to use this guy because they all have hypotenuse. I don't want to know hypotenuse, I want to know one of the legs. So I'm either going to use tangent or cotangent. So it just depends on which angle you use. You can use, because I know two of them, right? I can use C or I can use E. Doesn't matter which one you use. Okay, I'll use C. Okay, so if I use C, I know from C, I know the opposite side, right? And I need to know the adjacent side. That's tangent. So I need to know opposite over adjacent. And in fact, it's not C. I know what C is. C is 23 degrees. So I'm going to solve for x now. So I'm going to do the same thing I did last time. Cross multiply, solve for x. So I get x times tangent of 23 degrees equals 9.5 times 1. Divide by what you don't want to stay. Since it's multiplication, since it's x times tangent. So we're going to go to my calculator and put that in there. And so it's 9.5 divided by tangent of 23. Tangent of 23, and again, it's already in degrees, so I'm good there. 22.38, so I'm going to round up to 22.4. 22.4. That's what the missing side is. Okay. Okay, all right, so now, last two are similar problems, but we have to build the picture. They're describing a picture, we have to build it. Okay, so from her eye, which stands 1.69 meters from the ground, Sadie measures the angle of elevation to the top of a prominent skyscraper to be 36 degrees. Okay, so that means Sadie's looking up. Angle of elevation means looking up. The opposite would be angle of depression, which means you're looking down. So angle of elevation means she's looking up. So she's on the ground here. She's looking up to the top of a skyscraper, top of a big building, right? So that angle that she's looking up, is 36 degrees. That's what it's saying. Okay, so this angle here is 36 degrees. That's what they're saying. The building is standing straight up. Buildings, the way they build buildings is standing straight up or else they'd fall over. So that's going to be your 90 degrees. So 90 degrees is here because this is the building. Okay. She is standing at a horizontal distance. Horizontal is left to right, side to side. So the distance, so horizontal distance of 275 meters from the base of the skyscraper. So that means from the ground to where the skyscraper starts. That distance there is 275 meters. Okay, so it's the same distance here, 275 meters. How tall is this skyscraper? So how tall is this guy there? That's what they want to know. Okay, so this picture looks very similar to this picture. Just different numbers, but it's the same type of thing. They want you to find the missing side. So the missing side is how tall. So we'll call that x. Okay, so I know 36 degrees, right? I can figure out what the other angle is, but I'm going to use 36. So if I know 36, I'm going to use that one. So I need to figure out what the opposite is, right? And I know what the adjacent is. So opposite and adjacent, that's tangent. So tangent of 36 degrees, opposite is x, adjacent is 275. Solve for what you're missing. Okay, so I'm going to turn this guy into a fraction. I'm going to multiply both sides. So I get x times 1, which is just x. And then I get 275 times tangent of 36 degrees. Put in your calculator. You're going to round to the nearest hundredth. Okay, so 275 times tangent of 36. So the hundredth is, so 199.79. The 9 after the 7, that's the hundredth. So we're going to raise up. That means you're going to go to 0. That means 199.8. 199.8. And since we know it's meters, we're going to put meters in there as well. Okay. Last problem. Okay, last problem. Okay, so Hakeem leans against a ladder, leans a 26-foot ladder against a wall, so it forms an angle of 72 degrees on the ground. Okay, so let me draw a little picture here. So let me use some different colors. Okay, so here's the ladder. Ladders lie, they don't lie, they're not straight up, right? The ladders need to rest against something. So you got the ladder there, you got the ground here, and then you have the wall here, right? Makes a 90-degree angle. The ground and the wall always make 90-degree angles. Okay. It says the ladder is 26 feet long. The ladder is the orange. So that's 26 feet. The angle where the ladder meets the ground that's going to be this angle here, is 72. Okay? What is the horizontal distance between the base of the ladder and the bottom of the wall? So the base means the bottom. So the bottom of the ladder is here, and the base of the wall is here. So they're looking for this distance here. That's what they want to figure out. How long is that? So from 72, so if I use 72, use what they give me, I know adjacent, or I need to find adjacent, and I know hypotenuse. So adjacent and a hypotenuse, that's cosine. So cosine of 72 degrees equals adjacent over hypotenuse. Cross multiply. X equals, so I get 26 times cosine of 72 degrees. Okay, so 26 times cosine 72. So 26 cosine 72. 8.03. feet. That means the ladder is a little more than 8 feet away from the wall. The base of the ladder, the bottom of the ladder. Okay?